Hey everyone, my name is Sam. It's Sunday, and on Sundays we do a little sequel. In this video, I thought I'd cover the 3 common mistakes I see analysts do when querying data and doing their analysis. So the first common mistake I see is not using appropriate filters when they query. So for example, let's say I want to look at the Ethereum table, so like the fact transactions table. Now if I run this, what it does, it looks through the whole table and it just takes a random 10. Now if I run this, you're gonna get results pretty quickly because the number of rows in this table is just it's pretty manageable, right? So you're gonna get results pretty quickly. But as soon as you use tables such as tables in Solana, where each row each day has a lot of rows, you're gonna want to use appropriate filters, right? So most of the tables here are clustered by timestamp. And what that means is if you have a timestamp filter, for example, like, where block timestamp is a particular date, like so, or after this particular date, you're just going to get results much quicker. And that's because it tells the table which sections to look for. In this case, it looks for only entries after this particular date. So even if you just want to see, if for example, if you find yourself running a simple select star from table limit 10 and it takes quite a while to run, insert a block timestamp and that would speed up your query time and save you a lot of time. The second mistake that I see people make, not really a mistake I suppose, but more of a inconvenience to yourself and to others if you do ask for help, is not properly formatting your query and also not properly naming your query. So for example, I have a query here, I have a CTE here, right, with AS and then select from A, so it's a CTE and then you select from the CTE. Now this looks pretty straightforward, but notice how I've named this CTE as A, and that doesn't tell me what the function of this CTE is. If you look closer, you will also see that all the columns here are in one line. And thirdly, the name of the column or the alias that you gave this particular column, or I gave it, is AA, which is very not helpful, right? It doesn't tell me exactly what this variable is. It doesn't tell me what the function of the CTE is. So, a good practice is to, of course, have each column in one row. And then some might argue, have your commas on the left side over here. You can do that as well. But I feel the more important thing is, of course, renaming your CTE and renaming your variables. So for example, here I might say with transactions, base, right? And then if I'm counting my transaction hash, maybe I say tx hash count, right? And then same goes to ETH value. Let's go with sum. So that's when you're debugging your query, or if you're sharing this query, it's going to be way easier for yourself and other people to know what's happening here. There is also a format button here where it indents the variable for you nicely. It's over here. Okay. And one more point I want to make on formatting is I see also a lot of queries where people have nested queries. So they would do something like this, like select all from, and then this is the table, right? no, this just looks very ugly. And if it's just one level deep, is still okay. But if there's like multiple nested queries, you can imagine there is another, another subquery here, right? And then it just goes on and on. That's just a nightmare to debug if there's something wrong with your query. And also, if you want to refer it back, right, in the future, if you do look back at your queries, you wouldn't know what's exactly happening. Now, before you move on to the last common mistake, going back to the first mistake, another tip from me is, so this first mistake is around applying proper filters. So a common analysis is to look at new users, right? Like when did a user transact? So something like um, from address, and then give me the earliest timestamp where they interact with a particular contract, right? This case, let's just use blur. Sorry, the blast bridge, right? Which is Blur's latest L2 announcement. And you can run this, just fine, group by from address. But to speed up even more, you can apply the same logic of using a timestamp. And the way you do that is you just look at the when this contract was created. So you click on, so this is the same contract on Etherscan. Click on this transaction where it says contract creator. So this address created this contract at this particular transaction. And you would see that it's on November 19th. So then back to your query, you can add a filter, right? And you say, I only want you to look at timestamp after November 19th, because that's when I know this contract was first created, and so you don't have to waste time looking at dates prior to this, right? So that's just going to speed up your query even more. All right, back. So let's now talk about the last common mistake, and I feel this is the most severe mistake, which is assuming all token transfers as deposits. So what I mean by that is, so a lot of analysis that I see nowadays is looking at breached value. So how much value was breached over to Blast, for example. And a lot of the analysis just look at token transfers, right? But the reality is token transfer does not equate to deposit. Even though most people would interact with the bridge and deposit, there are people who submits or transfers tokens directly to the address, and that doesn't count as a deposit, right? You have to go through the action of depositing, right? To make my case, to make my point, I have a token transfer stable over here where my to address is the blast bridge, right? And I found out that there are people who deposited the blur token. So let's just look at one transaction. So you see over here, this address deposited blur token to the blast bridge, and essentially this token is now useless because it's not being deposited into blast. It's just transferred to the account or to the address. If we see over here token holdings of the blast bridge, you will see there is some amount of blur, and this is just I guess wasted tokens or wasted money. Now, the argument you can make against what I've just said is, of course, the amount is not huge, right? There are not many people doing this, but you never know if someone might fat finger like a transaction sending a wrong address, and it coincidentally sent it to a breach, right? So all those can happen, and the way you would mitigate this is not assume all token transfers as deposits. Instead, here's another alternative solution, right? So an easy way is first look at how tokens are being deposited in the bridge. So a first alternative is to filter by the function signature, right? So you can see it says here deposit if is this function. Maybe I'll just copy it, right? This is deposit if, and let's try to find another one where it says deposit USD, like here deposit USDC or deposit USDT, I assume. Yeah, so it looks like for um, each stable coin, there is a different function signature, right? USDT uses this, USDC uses this. So what you can do is, for example, token transfers to this address and contract address in, and then you can filter, for example, uh, USDT like this, right? And then USDC, USDT, USDC, and then you can do another layer of filter where you say end function signature. If you look through this easy transfers table, there is a function signature here, origin function signature. So origin function signature equals to, sorry, in, and this would constitute all of your different origin function signatures like this, right? This would be for ETH, but you can replicate this for USDT, USDC, right? You would just put it here. So at least this way, there is more certainty that the token transfers to this bridge is a deposit event, right? Now, the more sophisticated way and the method that I do recommend is to use the decoded event logs table or the um, the regular fact event logs table, right? If you want to deal with raw data. But we're going to do a sample with the decoded logs table, and I am going to grab a random transaction like this one over here. Timestamp is today, so I'm going to filter where I'm going to take my own advice of applying filter and say timestamp today, and transaction hash is this, right? And we'll run this. Where is it again? Okay. So event logs table would look at the event logs that are emitted, and what we're looking for is an event that comes from the contract. So the contract is 576A, and um, the event emitted from the contract would be this one over here, right? 5F6A, and the event is USD deposited. So we will look through our table and look for the event where it says uh, okay. So what's happening here is we do not have the ABIs for this uh, contract address, and oh, there you go. Submit ABI to decode. So I'm going to submit the ABI for the contract address right after this, but I'm going to explain what's happening here. I was using the event logs table and there is no contract address. That means we do not have the ABI for Blast, the Blast bridge. And so what other options you have? Well, one is you would use the token transfers with a lot of the filters like contract address and function signature, like I showed before. Or you can go hardcore and use the event logs table. And I'm going to filter by contract address, which is the Blast address, which is this one over here. And using topics and data, I can derive this information, shares, amount, and DAI amount. See, users, yeah. So nothing in topics would be useful to us. All the useful information would be in the data. Yep, so let's do this. It's turned out to be a bit more complicated than I thought, but I think this is good because I can then show you how to use the raw event logs. So I'm going to go back to my previous videos SQL and grab this function over here, this cool function, and I'm going to say, so I'm going to grab what I want. So I want the, I guess, timestamp, I want the transaction hash, event index, what else do I want? I think that's it. And we're going to paste our cool function here, which if you followed the first video, it just takes a column, like data column, truncates, takes out the first 11, right? For the sake of traces, we need to take out 11, oh sorry, 10. But for data, we just need to take out the first two. And so we just need the string from position 3 onwards. And so this will be 3. And I think that's it. I will run this and see what we get. Alright, so we have three items in an array, and looking at Etherscan, it matches the three things that it has here. So the first item in the array will be shares, second item will be amount, third item will be DAI amount. So in this transaction, what happens is this person transferred 1,000 USDT, and when Blast swaps it to DAI, it receives 1,018 instead. Hence why this is hence why this is the number it shows right here. So we're interested in just this number, or you can say I'm interested in the actual raw amount that is deposited. You can do that as well, but in our case, let's just go with the amount of DAI that the bridge eventually received, right? So DAI amount is the third in data, and this is in hex value. We need to convert this to int. So how do we do that? First, we need to grab the third item in the array, which is 2, because 0, 1, 2. I can't say a string because there is a quotation mark here, so I just want to remove that. And then you can use your utils. So live query dot utils, oops, dot UDF hex to int. This function you don't have to memorize. It's all here. Click on this utilities, and then it's this one over here, UDF hex to int. What it does is converts this hex into an integer, and the integer would be this over here. So let's run this thing and call this as like raw die amount. Alright, so let's see what we have. 3,000. Am I looking at the wrong transaction? Oh yeah, I am. I'm supposed to look at 677, which is this one over here. So let me close this so I don't get confused. I am looking at this one. Yeah, 3. I guess 3 followed by a lot of zeros. Let's just confirm that with the overview. And yeah, so person deposited 3,000 USDC, and Blast does his thing and gets DAI in return. Exactly 3,000 DAI. So in this case, the DAI amount emitted is indeed, I guess 3,000. And that's why we get 3,000 over here, right? Of course, this is in its raw amounts. We need to divide by the number of decimals that DAI has. How to do that? Just click on DAI, and it'll tell you how many decimals it has. 18 decimals. So just need to divide it by 10 above 18. Numeric value is not nice. All right, there you go. I'm not sure why 1E18 doesn't work, but you can also use format like this. You say power 1018, so this will be 10 to the power of 18. And we will get 3,000 DAI, right? So now I'm just filtering for one transaction, right? If I were to remove this and if I were to set my timestamp to the correct timestamp, it would in theory get all of the DAI deposited into Blast, where there is a conversion of USDT or USDC to DAI. Now you would have to look at the Ether deposit. So for example, like this one over here, ETH deposited, and then I assume you would just use this amount over here, right? Same process, you would just have to use filter by topic. So if it's ETH, use this topic, right? If it's um, if it's a USDT or USDC, use uh, this topic, right? Which is what I forgot over here. And topics 0. That okay. So yeah, so that should tell you, you know, um, and that's how you would use the event logs table to filter for the exact event you're looking at. In this case, we were looking at this particular event, and we use the raw data to, convert it back to the amount, right, that we need. Now, this came out to be, more difficult than expected because we didn't have the ABI yet, but I'm going to submit that, and once we do have the ABI, it will be just, in the data itself or in the table itself, it will look something like shares amount, DAI amount. So you can imagine you would just have to query something like decoded log DAI amount int, and you will get the DAI amount, right, without all this conversion. But anyhow, always good to learn how the raw tables work, and so you'll be able to, derive accurate deposits, derive accurate data, right, in your analysis. That's all from me today, and yeah, thanks for watching. See ya.